All right, Harmony Science Academy Algebra 2. We have now solution processes, okay, involving exponentials and logarithms. So bottom line, we're going to solve exponential and logarithmic equations, okay? So now, after all this time of triangles and squares, we're going to benefit from it. Let me show you how, okay? So imagine, first of all, that you have to solve this, okay? You can use a calculator, but how do you enter that, right? Well, one thing you're going to learn in this lesson is, in this case, since we have an exponential, you're going to take log base 10 of both sides. Okay? Since that's a base, that's a base. So technically this should cancel. It doesn't cancel here, but it will here, and we'll look at why. Okay? We'll talk about this one in a little bit. So the main thing for you guys is you can put down the calculator, but what is this? Okay? So let's go ahead and we're going to need this, by the way. Okay? So this is our focus right now, this right here. Okay? Most of us are wondering, what is this? What do we do with this? Okay? So this is what this means. This means that log base 10, right, of what's in here, okay, 10x, this, equals what? We don't even know what that equals. Okay, so I've got a triangle, right? We've seen that before. Now, since it's hard to understand what to do here, what it equals, we're going to use our understanding of the inverse, right, the exponential, to provide clarity. So, right, the base is 10. Okay, the triangle we don't know, but it should equal the box. Okay, so what needs to go in the triangle so that we can get 10 to the x? An x. Okay, so this, notice that this big triangle is x. All of this is x, right? We said that all of this, we didn't know what it was, but now we know what it is. It's x. So then all of this becomes just x equals log base 10 of 3. Put that in the calculator and you get your answer. Okay? So we're going to play the same game on this side. Okay? And by the way, this is the focus. Okay? The trick, understanding it's not going to be necessary. Okay? But I'm providing it here at least one time. So what if you had to solve this one? Okay? How do you enter that in the calculator, right? You're stuck. So in this case, we're going to introduce a base 10. All right? Because it cancels, but some of you guys are not too sure. So once again, our concern is, what is this? Right? What is all this? So we're going to focus on this. Ignore this for now. Okay? So 10, right? Triangle. We've got the log base 10 of x, okay, equals some box, right? So we are wondering, what does this equal? Well, whatever goes in the box. But this doesn't help us, so we're going to use our understanding of inverses, or in this case, a logarithm, okay? So I'm going to write it as a log base 10 of box should equal what? The triangle, which is log base 10 of x. So how do I get what needs to go in this box? Log base 10 of something to equal log base 10 of x. Obviously it's x. So box is x. That means box is x here. And all this that we didn't know what it was, all of this becomes x. So we can say that x, in this case, okay, they're not the same cases, they're different cases, but in this case x equals 10 cubed. Okay, so here's evidence that these tricks work. All you care about is the trick. Okay, so now let's go ahead and put this into practice. Alright, so we have these two to look at. Now, before you get your hands dirty, you want to simplify. Okay, isolate those logarithms, isolate those exponentials. So the first thing we're going to do is add 4 to both sides. Okay. Now here you want to notice that we're stuck. Okay, so what's going to help us get unstuck is using this base 5. Okay, we just looked at essentially a proof or evidence, okay, of how this will cancel. We'll have a base 5 over here. It's going to cancel there. That's all you care about for the CBA 8, okay, that this will cancel. You got this base here, and we're going to be left with 8 plus 4. 5 to the negative 1 is 1/5. Okay. In this case, there's different approaches we can take. The easiest one is maybe to multiply 5 to both sides, which is going to give us 5a plus 20 equals 1. Okay. We're going to subtract 20, which gives us 5a equals negative 19. Divide by 5, and a equals negative 19 fifths. Okay. Maybe it seems like a lot. Hang in there. Okay. Let's look at another example. Right. For the first thing I'm going to do here is, remember, this stuff in parentheses is very important because it belongs to the logarithm. Okay. You can play with this stuff that's outside of that. So in this case, I'm going to subtract 7. So I have log base 4, 8 plus 6 equals negative 1. Okay. Now in this case, I'm going to introduce a base 4 to cancel. All right. And we're going to have 8 plus 6 equals 1/4. Okay. Same thing, I'm going to multiply by 4 to both sides, so I get 4a plus 24 equals 1. Okay, we're going to subtract 24 and divide by 4. Okay. So we'll probably have to do some more in class, that's fine. Let's at least get your eyes exposed. Now, we have this situation. Okay. Before my battery dies, okay, we've got number 21. Same thing. We want to go ahead and clean up everything and leave that exponential portion by itself. So we're going to divide by 4. Now I'm going to go ahead and introduce log base 8 so that it can cancel here. And same thing over here. Log base 8. So I'm left with negative 9x minus 8 equals log base 8 of 22. Now I'm going to do just what I know to do with algebra. Okay, I'm going to add 8. This can go in the calculator, by the way, plus 8. Now I'm going to divide by negative 9. So I have x equals log base 8 of 22. And these parentheses just help you keep track of stuff so that, for example, this plus 8 doesn't come in here, okay? Over -9, okay? And you guys, like all of us, love the calculator. That's exactly the time you plunge it in. Let's go ahead and try this one. So I'm going to go ahead and add 10. Okay, don't overthink it. Just trust these little, this trick that we're introducing, okay? We've got 49. Now I'm going to go with what? Log base 7. So that it cancels. It doesn't cancel on this side necessarily, at least not yet. So we have 4x minus 1 equals, okay. Now, in this case, this is a cool problem because you have to be on the lookout. Remember, this is 7 to some exponent equals 49. In this case, 7, or excuse me, yeah, 49 is divided by 7 perfectly, so we do have a perfect product, okay? So then we're going to be able to go ahead and, okay, notice how this one's a little different, so you have to be on the lookout. So technically this is 2. Okay, you guys can turn this into an exponential and prove it to yourselves. Now I'm going to add 1, which gives me 3, and divide by 4. Okay. So there's a lot going on here. We might actually spend an additional day on this, so definitely get your feet wet. Okay, take a deep breath, be calm. We'll catch you in class.